Hey everybody, this is Doug with Artfully Rogue. So if you're just getting into welding for the very first time, or you're interested in looking into it, I would suggest you start with gasless flux core welding. Here's why. One, it's a super simple, easy setup. All right, the machines are relatively cheap, the materials are relatively cheap, you don't have to worry about gas bottles or hoses or regulators. So it's a great, easy way to kind of get your feet wet into the world of welding. Now, it's typically referred to as a type of MIG welding, which is really not accurate. MIG welding is metal inert gas. You have a wire that you're going through a gun and it's shielded by a gas, hence the tanks that you need to help protect that. Now, without that gas, you have all this atmospheric dust and particles that could get into the weld and actually create what's called porosity, which is basically a bunch of holes in your weld that kind of make it look like a sponge. Now, if you don't have gas, the other option is flux core welding. Now, flux core welding does very similar things for your weld in the sense that you have your wire, which is actually a wire tube, and inside that wire tube is something called flux. It creates a shield for your weld, protecting it from the atmosphere and all the particles that could get in and screw up your weld. Okay, let's talk about the machine. Now, you can pick up a flux core welding machine just about anywhere now. If you're just starting out and you're a beginner and you don't know anything about machines, I would definitely keep it cheap, keep it inexpensive. Don't blow a lot of money on brand names and things like that just yet, all right? Go to Harbor Freight, go to Amazon, pick up something that is just flux core. That way it's gonna be more simple and easy to understand. It's also gonna be less dials that you have to mess with when you're just getting started, because you really don't need a lot of extra bells and whistles on your machine if you're just doing flux core and you're just starting out. Now, this particular machine is a 220 machine because I'm here in Europe right now. There you're gonna get a regular 110 or 120 volt setup. You don't need 220 power to start. Something that can plug just right into your household outlet. Now make sure you're not running, a lot of things off that same line, but you want something that you can just plug in and you can start. Okay, so once you have your machine, you want to get to know your machine. Now, most machines internally are about the same, but some are different on the outside. Now let me show you what I'm talking about. This particular machine has access door on the side. Your machine may have an access door on the top that actually flips up, but the inside components are going to be pretty much the same. You're going to have a place for your wire, you're going to have your feed controllers, you're going to have your whip, you're going to have your ground clip, which is what you want to connect your material to. You're also going to have your plug, and then you're going to have the front where you control all of the different components or different amperages and voltages for the machine. And typically on the back is the on and off button. So right now, I'm going to walk you through setting up this machine so you can get ready to weld. So chances are when you open up the box, you're going to have your welding machine itself, you're going to have the ground cord, and then you're going to have the whip. So let's go ahead and get those installed before we actually install the wire. Now, with the flux core, you got to make sure that the polarity is correct. Inside your machine, it'll probably tell you what you need to do to make sure that the polarity is correct. But on this machine, it makes it super simple because it marks it as gas and flux. But I know that your ground wire needs to be on your positive side. So make that connection so that your ground is in the positive and then your machine goes to the negative. Now with your whip, usually those are pretty simple. They're going to have some kind of configuration with pins and buttons and holes and knobs or whatever. You just want to make sure that you match that up. Don't force anything that doesn't want to go, because it should all slide in nice and easy, and then you should just be able to tighten that into place. All right, we're gonna set up your machine so you can get started welding. Now, you wanna make sure that when you get your wire, that it does say on here, sorry, I'm gonna turn this around here so you can see it, it says flux core. All right, that's important. You want to make sure you have flux core wire. Now this says 1 kilogram, yours is probably going to say 1 pound. This also says 9 millimeters, yours is probably going to say 0.35 or 0.30. I typically use 0.35. It's a good, rounded wire, I guess you could say. It works really well for most of the stuff that I do. A word of caution, when you get this wire, it's usually going to be inside of a plastic bag or a piece of paper, trying to keep moisture away from the wire. Typically the wire is going to be secured into the spool by this little hole, so you're going to have to take that out and cut it. As soon as you cut it, make sure you hold that wire. If you don't hold it, it's going to bird nest and it's going to go all over the place, and it's going to be a real pain to get back to normal. I doubt you can. I'm going to be real careful here because I don't want to do the same thing. When you open your machine, this is probably what you're going to see. You want to remove the keeper nut and the spring. Be careful not to drop those. Now, this has a little centering plate. Now, with the wire, you want that wire to feed off down the bottom because you want it to turn this way. So I'm going to put that on here. I'm going to put that little keeper here, the spring. Now, this is where you need to be a little bit flexible with your holding in your hands. You want to make sure that spring is on there nice and tight. Now, you don't have to get too crazy with this nut. You just want to make sure that it holds it in place. Now, notice I haven't let go of the wire yet. If I did, it's going to go crazy. Now, I'm going to zoom in here a little bit. I'm going to zoom in here just a little bit. I'm going to show you how to run this wire. Okay, with your wire, you want to straighten. I just dropped one piece of the whip, and you want to feed into your mechanism. Bring this down. This is on a spring, so be careful. Feed this through. Make sure it goes into the hole. Push it in a couple of inches. Bring this down and lock into place. Now you're good. Now you can let go. You don't have to worry about this. One of the things that you want to check out before actually loading the wire, and I should have showed you this before, is this little wheel, this little drive wheel. I'm going to take this back off for a second. I'm going to hold the wire while I do this because I took some tension off of this. I'm in the groove. Okay, let me see if I can show you this. You can see that's got a 0.8 on that side. This has a 1. Now, I don't know what the reference is. I think it's 9 millimeters or it's maybe 1 millimeter. But I want the 1. You want to make sure that yours has 3.5 if you're using 3.5 wire, or 3.0 if you're using 3.0 wire. And then you basically just put that back in place so that the wire runs across that groove. Lock it in, and now you're good to go. Make sure that you secure your little drive wheel back in place. This actually sets the tension on your wire. You want to make sure that there's enough tension so that when this drive well turns, it pulls the wire. I'll show you how to test that a little bit later in this setup process. But for the most part, you're done. Now we want to run the wire into the whip. Okay, with your wire installed, now you want to run it into the whip. One of the first things you want to do is you want to remove any obstructions that may occur. Now, I'm not sure why this welder has it. Maybe it has a gas setup. Thanks. But I think this is a gas shield because most flux core welders won't really have something like this. But you want to remove your tip, all right? Typically they just unscrew. You'll need to replace these periodically, so make sure you get a couple of spares because they're going to get gummed up, you know, from all the weld splatter. Keep that off to the side. Now, here's what I want you to keep in mind. You're going to plug your welder in and you're going to turn your welder on. Let your welder cycle up. It's going to take just a little bit. On your ground clip, make sure that it's nowhere near this side. Leave it unhooked, unattached. All right? With the machine on, you can simply push the trigger and it's going to feed this wire. Now you can speed this up by increasing the voltage on the machine. And that'll help make it go a little bit faster. You want to make sure that your whip has no kinks in it, no loops. This is not a roller coaster. It's just a nice simple tube that pushes wire through it. Now as soon as that wire comes out at the end, you want to stop. You want to turn back down your voltage, and you want to turn off your machine. Now that your machine is off, and I would say you can close that while you're doing it. I just wanted to show you what it looked like. Now, you want to add that tip back onto that wire and take your shielding this nozzle. Now you have wire. Now you're ready to weld. Now this particular machine is actually a multi-process machine. Now I know for you, I suggested getting a flux core welding machine that is specific to flux core, but if you happen to have a multi-process that does flux core, that's also fine. My machine is set up for flux core using 0.9 wire. It also has the option of flux core 1.0 and flux core 0.8. My machine also has the ability to do lift TIG, stick. But let's keep it on the flux core. Now every machine is going to be slightly different, but there's going to be two main adjustments on each machine that you're going to need to concern yourself with: amperage and voltage. Think of the amperage as the muscle behind the weld. The more amps, the hotter the arc, deeper penetration into the metal, and the thicker material that you can weld. If you turn down the amperage, it's going to be a cooler arc. It's going to be a little bit more shallow, which is much better for thinner pieces of metal. With regards to voltage, this is the finesse. The higher the voltage, the wider and flatter the weld bead is going to be. The lower the voltage, the more narrow and tall the weld bead is going to be. Voltage also helps balance splatter, bead shape, and the smoothness of the weld. So if you're welding and your weld beads look tall and ropey, you just want to turn that voltage up, and that'll start to lower them and widen them just a little bit. Let's go ahead and start welding, and we'll play around with these adjustments as we go so you can see the differences in the weld. Okay, for the sake of keeping it simple, we're just going to talk about the very basics of what you need. You need a welding helmet. Get yourself an auto darkening, all right? So as soon as you strike a spark, this goes dark and you can start welding. They're now very inexpensive, so I'm not sure. This is a Stayer brand that's here in Europe, but I would go to Harbor Freight or Home Depot and pick yourself up a welding helmet. Next, you need some welding gloves. Make sure you get something that's going to cover your hands and fit properly, all right? You want to cover yourself as much as you can. Now, this bare arm, you're going to see yourself get burnt if you don't have this covered up. So wear yourself a long sleeve shirt if you have it. You can also get welding sleeves. You can get welding jackets. You want to make sure that you're protected because this spark gets extremely hot. Now when it comes to what you're wearing, you want to make sure that you're wearing natural fibers, cotton, denim, things of that nature. You don't want to wear synthetics because synthetics will melt. And you're dealing with a lot of hot sparks, all right? And you don't want things to melt to you. Next, we're going to talk about metal prep, and then we're going to talk about the technique of welding, and you're going to start running the bead. All right, so when you're just starting, you want to go to your local metal supplier or scrap yard or maybe a salvage yard in your area, and you want to find just some scrap pieces. You don't have to go out and buy something, or you really shouldn't have to. If you do need to, get something cheap, get something easy. Let's start with welding steel, all right? Here I have a few pieces of scrap steel. This is a flat bar, which has mill scale on it, all right? I have some angle, and then I have some square tubing. Now the angle has mill scale, and the square tubing does not. Most of your square tubing is going to be protected from rust by having an oil on it. So when you buy it from your supplier, it's going to be lightly coated in oil. You want to make sure that you remove that. And before you start welding, you want to make sure that you actually start removing the mill scale. Now mill scale is a part of the process that helps protect the steel from rusting. Now, the cool thing about flux core is if you didn't prepare your metal, like you didn't take off the mill scale or you didn't take off the oil, it'll still weld. I've done it. It works. It's one of the cool things about flux core. You really don't need to prep your steel. You can just start welding. It also works really well outside. So if you have a light breeze, it works. So gas shielded MIG wire won't necessarily work outside because the breeze or the wind will blow away the gas. Therefore, your wire's not shielded and you'll get more porosity. So flux core is very good for outside. So now I had used this in another video. You can check that out up here somewhere, and it's going to go into more details about the tools that you would need to get going in welding. But we're going to go ahead and start prepping this steel, and we're going to run some beads. Okay, so as you can see, I've taken the mill scale off of this angle. And I don't know if you can see here, but I also put a slight bevel on this edge. All right, I did the same thing here with this flat. All right, took away the mill scale and then put a small bevel on this flat. All right, that's how you prep your steel for welding. Now, same thing here. You just want to knock off any oil. You want to make sure you got a nice clean surface to weld to. And now you've got pieces prepped to go ahead and start welding. Okay, so now you have the wire in the machine. You know how to operate the machine and kind of adjust the knobs on the machine. You have an idea about what equipment you need, helmet, gloves, the proper attire. You have your metal prepped, and now we're going to work on some technique. Okay, so the first thing you want to do is clamp your material to your work table. All right, this is going to do two things. One, it's going to make sure that you don't have to use your hands to hold it while you're welding. All right. Two, it's going to also keep your material from warping, and we'll kind of get to that in a little bit. I've added another piece of test material. This is a 16 gauge piece of sheet. Now, it's pretty rusty, but I did clean off the edge where I'm going to be welding and working. So what I want to do first is I want to be adding 2 tack welds to this sheet that's going right to the square tubing. Now, before you actually make any weld, you want to make sure that you cut your wire so you have a nice clean edge. You want to have about 3/8 of wire exposed at the end of the torch. All right, so it's key to make sure that you are stable and secure when you're welding. You don't want to be floating up here in the air. So make sure you place your hand in front of your workpiece or to the side of your workpiece. Make sure that you rest your torch gun in your hand, almost like a pull cue, and then you can angle your torch gun just under 45 degrees. I'm going to shoot some of that out. Here's your corner, and you want to be moving your weld from top to bottom as you pull that weld. Now, right now, I'm directly at the weld, so what I want to do is I want to kind of come at it from a backside angle here. I want to go bottom, top, bottom, top, bottom, top, and you'll get to a point where you actually start to see the puddle of weld, and you want to stay just ahead of that and basically kind of walk that puddle along that corner as you move. This is sometimes the hardest part to get down because you're not quite sure where you're looking. But in your screen, you're going to see that puddle, and you just want to walk it down that corner. Let me show you what I'm talking about here. So you can see what I mean when I'm talking about going from your top down to your bottom. All right, I kind of did almost like little arches or little arcs as I did this weld, back and forth, back and forth. You don't want to go too slow, you don't want to go too fast, you want to try to find your rhythm. Now with this slag on here, you can't really see the detail of the weld. So I'm going to go ahead and take the wire brush, and I'm going to go ahead and take this slag off. Subscribe. So as you can see, you can kind of see that pattern. I kind of hit a bump here, but then started to get back into that pattern, then hit a little bump here, got back into that pattern. So this is characteristic of flux core. You get a lot of splatter, but most of the time this can knock right off and you can clean up your weld. Now let's run some tests with some different settings on the welder. All right, I'm going to start out with low on the voltage, low on the amperage. Next, we're going to turn up the voltage about midway. We're going to turn up the amperage to about 90. Now, let's crank it all the way up. All right, so on the left is the last weld. Everything was maxed, high voltage, high amps, and you can see that wire was coming out like fast, and I wasn't moving fast enough for it or moving too slow for the wire that was coming out. This is great for thicker material, but in this situation, you can see it's a much wider weld. Now the middle one was also right in the middle of the voltage, right in the middle of the amps. I think that was 90 amps we had. And you can see that weld is much thinner, and it's a little bit higher as well. So this particular setting for this particular steel didn't do too bad. And then on the right, you can see with the voltage all the way down and the amperage all the way down. So now I'm going to do another test where I do low voltage, high amperage. And let's bring that voltage back up to the middle range. And let's bring that back down to about 90. And we're going to take this up to max. So this is one of the last welds. We did high amperage, high voltage. Here we did high amperage, low voltage. And here we did high amperage, middle voltage, and this went down to say 90, 92 amps, and then also high voltage. And so as you can see, your welds are going to look different depending on the type of amperage and voltage you set for the type of material that you are actually working with. This is why it's so helpful that most manufacturers will actually put a chart inside the welding machine, typically where you load the wire, that will give you the breakdown of what your amperage and your voltage need to be for your particular machine. It often looks like this. And so go by their recommendations so you can set your machine up so that you can work on the material that you're going to be working on. Okay, so there you go. That's the basics of gasless flux core welding. Hopefully this video was helpful. Hopefully it will intrigue your interest enough to go out and get yourself a welder and start welding and playing around a little bit. If you like what you saw, give me a thumbs up. If you haven't subscribed, please do so now. And I've just opened up channel membership so you can get exclusive content. So go ahead and check that out while you're at it. And I'll see you in the next video. All right, before you start welding, you want to clamp your material. Clamping your material is going to do a couple of things. One, it's going to do something. Let's try to do that again. First take of the day. My mind is a little bit groggy.